and I'll post this recording to YouTube later today. Within a couple of hours, I'll have it posted. I'm going to share my screen. And we are going to continue our discussion of the binomial distribution. So on Tuesday, we had gotten the definition of what the binomial distribution is. And the binomial distribution is a discrete probability distribution where you have one of two outcomes, either a success or a failure. So you could look at this as even flipping a fair coin. If you're flipping a fair coin, you get one of two outcomes. Either you get a head or you get a tail. And if what I'm interested in is the number of heads I get on so many trials, then I could consider a head to be a success. So the probability of me getting a head would be 0.5. So the probability of me getting a success on any individual trial would also be a half. So we use a capital B to represent a binomial probability distribution. And then we have this notation we are going to be using for the rest of the course, describing what the random variable is. So our random variable, which we use a capital X to denote a random variable, is a binomial distribution. And the binomial distribution only depends on two parameters: the number of trials that you do and the probability of a success. So everything in the binomial distribution depends on those two things. And so once we know the probability of a success and the number of trials we do, we can calculate the probability of any value that my random variable can take on. All right. So the example we had started looking at on Tuesday was this example. It has been stated that about 41% of adult workers have a high school diploma, but do not pursue any further education. So in our population, we have observed that about 41% of people who are in the workplace and are considered adults, so 18 and over, I would assume. So 41% of adult workers say that they've completed high school, got a diploma, but they haven't gone on in their education. All right, so now we're going to look at 20 of these adult workers. So we're going to take a sample of 20 people and we are going to look at them as a sample. So now we can use the binomial distribution to calculate the probability that our random variable takes on anywhere from values 0 through 20. So what we're interested in is finding the probability that at most 12 of them have high school diplomas. Well, we're actually going to also look at what's the probability that out of these 20 that I've randomly selected, exactly 12 of them have a high school diploma but haven't pursued any education beyond high school. So we're going to let our random variable X be the number of workers who have a high school diploma but do not pursue any further education, because that is the topic of interest. So that's what we're going to let our random variable be. All right, so since this is a binomial distribution, where a success, we would consider a success to be that a person has a high school diploma but does not pursue any further education. So I'm using success with the quotes around it. That's what we're interested in. So that's what we're going to consider to be a success. So then a failure would be that I have an adult worker who has a high school diploma, but they have pursued further education. Obviously, that's not a failure. But in this situation, since we're considering the success to be the 41%, we would consider the failures to be the 59% who have the diploma but have pursued more education beyond high school. So X can take on the value, since I've selected a sample of 20 adult workers, my random variable can take on values anywhere from 0 to 20. So out of these 20, none of them could have a high school diploma but have not pursued any further education. Or one of them could fit this category, that they have a high school diploma but they haven't pursued any further education. Or two of them out of the 20 could meet this criteria of having a high school diploma but not pursuing any further education. So my random variable can take on any value from 0 to 20. And the number of trials that I have here is the sample that I've taken. So the number of trials is 20. And since we're interested in looking at adult workers who have a high school diploma but have not pursued any further education, then the probability of a success is the 41%, or 0.41. And then the probability of a failure, Q, is 1 minus P. So the probability of a failure, Q, is 0.59. So we have a binomial distribution where we're looking at a trial of 20. So we are looking at a sample size of 20, and a probability of a success is the 41%, or 0.41. So our random variable is a binomial distribution with the number of trials being 20 and the probability of a success being 0.41. So we're going to find a couple of different probabilities. We're going to find the probability that if I select these 20 workers, exactly 12 of them fit this criteria of having a diploma but not pursuing any further education. We're also going to find the probability that at most 12 of them have a high school diploma but haven't pursued any further education. So we're going to find the probability that X is exactly 12. So exactly 12 of these 20 fit this criteria. And then we're going to find the probability that at most 12 of them, so 12 or less of them, fit this criteria. Now, as a reminder, when you're looking at a binomial distribution, you can find the mean of this distribution by using the formula. So the mean of this particular distribution, this binomial distribution, where I have 20 trials and the probability of a success is 0.41, we can calculate that by taking the number of trials and multiplying it by the probability of a success. So the mean for this distribution would be 20 times the 0.41. So the mean of this particular distribution is 8.2. And we can find the standard deviation of this binomial distribution by taking the square root of n times p times q. So we're going to take the square root of 20 times the 0.41, and the probability of a failure is q. That would be 0.59. So we would take our handy dandy calculators out, and we'd take the square root of 20 times 0.41 times 0.5. And my calculator says this is approximately 2.1995. So we can find the mean and standard deviation of this particular binomial distribution by using these two formulas. All right, so now let's see if we can't find the probability of X being exactly 12 and X being less than or equal to 12. And to do this, I'm going to use my calculator. There is a formula for the binomial distribution. The formula is for this first case right here, and it uses factorials, and we did look at that formula on Tuesday. It works pretty well when you're looking for the probability of X equaling a value. Where it doesn't work so well is when you're looking at less than or greater than. And it doesn't work so well for less than or greater than because you have to add them all up. So to find the probability that X is less than or equal to 12, so at most 12 of these people in this sample of 20 have a high school diploma but no further education, I would have to find the probability of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 and add them all up. Yeah, I don't want to do that. So I'm going to use my calculator to calculate these two probabilities. So I'm going to go open my calculator up. All right, so the distribution menu is found above your variables menu. So DISTR is your distributions menu. So I'm going to go second, variables, and then that's going to open up my statistical distributions, my probability distributions. And we are going to look at most of these later. The normal we're going to look at. We'll look at the inverse normal, inverse t. We will look at the student's t, which is 5 and 6. We'll look at the chi-squared. That's the Greek letter chi. We'll look at that later. We are not going to look at the F distribution. And then A and B are our binomial distributions. And if we keep scrolling down, you can see the Poisson and you can see the geometric. So in discrete probability distributions, we are interested in the binomial, the Poisson, and the geometric. What this calculator does not do is the hypergeometric. There's a formula that works really well for that. There's also, you can also do that in Excel. Excel will find the hypergeometric probability distribution. So when we get to the hypergeometric, we'll pull out Excel and let Excel do it for us. Okay, so here are 3 of the distributions we're interested in that are discrete probability distributions. And I'm going to concentrate on the 2 binomials. So the first binomial distribution, binom PDF, is the distribution we look at or we use when we're interested in finding our random variable taking on an exact value. So if we're looking for the probability that X equals some value, we're going to use the binom PDF. The binom CDF is the distribution we use when we're interested in finding at most. So X is less than or equal to a value. So first, let's find the probability in the distribution that we're looking at, where we're looking at folks who have high school diplomas but haven't continued in their education. We're going to find the probability that X is equal to 12. So we're going to first use binom PDF. So on my calculator, when I hit binom PDF, I've already put this in, by the way. When I hit binom PDF, it opens this little dialog window for me so that I can input my values. And when I paste this back in the home screen, some of you will have calculators that you will have to fill it in when you paste it in your home screen. We'll talk about that in just a second. All right, so we're looking at a sample of 20. Those are the folks we're looking at. The probability that they have a high school diploma but haven't pursued any further education is 41%, 0.41. We're interested in, out of these 20, what's the probability that exactly 12 of them fit this category? So our number of trials is 20. The probability of a success is 0.41. We're interested in the probability that the random variable takes on the value of 12. I'm going to paste that back in my home screen. And this is what it should look like. So we're going to have a binom PDF, open the parentheses. The first number there is the number of trials. The second number there is the probability of a success. The third number is the value that we're going to let our random variable take on. So we're interested in our random variable being the number 12. So when I hit enter, it should be pretty low. So the probability out of these 20 people that I get exactly 12 of them that fit this category is 0.04. All right. So if I go back to my, well, I should probably write down a few more variables. Let me write down 4 decimal places. So if I go back over here, the probability that X is exactly 12, so exactly 12 of these 20 fit this criteria of having a high school diploma but not pursuing any further education, that is equal to 0.0417. All right, now if I want to find the probability that X is less than or equal to 12, so for a less than type probability, I'm going to use binom CDF. So I'm going to go back to my calculator, and I'm going to go back to my distributions, and I'm going to find binom CDF. And you fill it out the same way, but the C stands for cumulative. That's what it stands for. Okay, so the number of trials, I'm looking at 20 people. The probability that they have a high school diploma, but they haven't pursued any further education is 0.41. I'm interested in at most 12. So I'm interested in my random variable being 12 or less. We're going to paste that back into our home screen. So you can see the difference here between the original one I did, binom PDF, and binom CDF. The values, the number of trials, the probability of success, and our random variable value are all the same, but now it's going to calculate all the probabilities of 12 or less. So from 0 to 12, it's going to calculate all those probabilities and add them together. And it should be a fairly big number, I would think, 0.9738. So the probability of me getting at most 12 or less is 0.9738. All right, so back to our PowerPoint. This is 0.9738. All right, so the next slides are going to be summary slides of how you do this in your calculator. So for this particular example, our random variable can take on the values from 0 to 20. The number of trials is 20. The probability of success is 0.41. The probability of a failure is 1 minus 0.41 or 0.59. Our random variable is a binomial distribution with 20 trials and a probability of success of 0.41. To calculate this, you're going to go to your distribution menu, which is second variables. It's the menu above the variables menu. To calculate an X equals a value, you're going to use binomial PDF. The first number in your binomial PDF will be the number of trials. The second number will be the probability of a success. And the third number is what value your random variable can take on. So we were interested in 12, so our number was 12. If you leave the number out, then it calculates the entire binomial probability table for that particular number of trials and that probability of a success. So it would calculate the cumulative, the probability of all of it. To calculate X is less than a value, then you're going to use binom CDF. The first number is the number of trials. The second number is the probability of success. And the third number is the value that I'm interested in my random variable taking on. So that would be the value up there above it. That number would be whatever that value is. Okay, so in our example, oops, we had binom CDF 20.4112. All right, so if you want to calculate the probability that X equals a value, you use binom PDF. If you want to find the probability that X is at most a value, X is less than or equal to a value, you use binom CDF. And if you're interested in finding X is greater than a value, then you're going to use 1 minus the binom CDF. So X is greater than 12 would be 1 minus X is less than or equal to 12. So to find the probability that your random variable takes on the value of 13, 14, 15, 16, 17, 18, 19, and 20, you're going to find the probability that X takes on the values of 0 through 12, that probability, and you're going to subtract that from 1. So the probability that X is greater than 12, we would use 1 minus the binom CDF 20.4112. Okay. So this is a graph of this binomial distribution. If you're interested in what this graph looks like, the y-axis is the probability that I get any one of these random variables, and the x is the values that my random variable can take on. So the horizontal axis goes from 0 to 20. And we did go ahead and already calculate the mean and the standard deviation of this particular distribution. For this particular distribution, the mean is the number of trials, which was 20 times the probability of a success, 0.41. We got 8.2. And the standard deviation we calculate using the formula, the square root of n times p times q. All right, let's look at another example. About 32% of students participate in a community volunteer program outside of school. If 30 are selected at random, find the probability that at most 14 of them participate in a community volunteer program outside of school. And we're going to use our calculator to calculate this. So I would say that this is a binomial. And it's a binomial because either the students participate or they don't. It's one or the other. So that would indicate to me that this is a binomial. So the probability of a success, in this case, I'm going to say the probability of a success is that they participate in a community volunteer program. So I'm going to say the probability of a success is the 0.32. So the probability of a failure, then, Q, would be 1 minus the 0.32, which would be 0.68. All right, and I don't necessarily need that just to find a probability. I do need this to find the standard deviation. So if I'm asked to find the standard deviation, I do need to know what the probability of a failure is. Okay, now I'm looking at 30 students. So I'm looking at the number of trials would be 30. So I'm looking at a binomial distribution where I have, sorry, I forgot which number comes first. The number of trials, which is 30, and the probability of a success. My brain went dead. Which number comes first in my binomial distribution? All right, so what am I interested in? I'm interested in the probability that at most 14 of these 30 volunteer in a community program. So I'm interested in the probability at most means less than or equal to 14. So I'm going to be doing a binom CDF. Number of trials is 20. The probability of a success is 0.32. And I'm interested in less than or equal to 14. So I'm going to go to my calculator. I'm going to go to my distributions. Binom CDF. So the number of trials, I'm looking at 30 students. The probability that they do participate in a community volunteer program was 32%, 0.32. And I'm interested in what's the probability that out of these 30, at most 14 of them participate. So that's going to be 14 for X. So paste that in. So I have a binom CDF 30.3214. So 0.9695. So the probability that at most 14 of them participate in a community volunteer program is 97%. All right. Some kind of weird feedback here. I know why. That cord stuck in my Surface Pro. Okay, we should be good to go now. All right, our last example of the binomial distribution. And then we are going to take a quick look at one of your homework problems. In the 2013 Jerry's Art-A-Rama Art Supplies catalog, there are 560 pages. So there are 560 pages in the catalog. Of those 560 pages, 8 of the pages feature signature artists. So suppose we randomly sample 100 pages. Let's let our random variable be the number of pages that feature signature artists. So what values do X take on? What is the probability distribution? Okay, so what values can X take on? If our random variable is equal to the number of pages that feature signature artists, and there are 8 of those that feature signature artists, then out of these 100 pages, none of them that we look at could feature these signature artists, or one of them could, or 2 of them could, or 3, or 4, or 5, or 6, or 7, or 8. And it can't take on a value larger than 8 because we only have 8 of these pages in this catalog of 560 pages that feature signature artists. So if the random variable is the number of pages that feature signature artists, out of the 100, we could see none, or we could see 1, or we could see 2, etc. So this is a binomial because we either get a page that has a feature artist on it, or we don't, one or the other. So this is a binomial. We're looking at a sample of 100 pages. And what's the probability of a success? So the probability of a success is the probability that the page in the catalog features a signature artist. So how many pages in this catalog feature signature artists? Well, that would be 8 out of the 560. So the probability of a success that we see a page that features a signature artist would be 8 out of 560. So the probability of me not seeing a page that features a signature artist would be what? 552 out of 560. So now knowing that, I can go ahead and calculate the mean and the standard deviation if I'm so inclined, and I am. So the mean is the number of trials times the probability of a success. We're looking at 100 pages out of the 560, and the probability that we get a page that features a signature artist is 8 out of 560. So that's approximately 1.4286. And the standard deviation is the square root of NPQ, which is the square root of N, which is 100. And I didn't leave myself enough room, so let's write it down here. So that's 100 times 8 over 560 times 552 over 560. So we would take the square root of 100 times 8 times 552, divide that by 560 squared. So I get that the standard deviation is approximately 1.1867. So the mean and standard deviation of this particular binomial distribution, the mean is 1.4286. The standard deviation is 1.1867, if I did those calculations correctly. Okay. All right, so let's find some probabilities. Let's find the probability that exactly 2 of these pages feature signature artists. So that would be the probability that my random variable takes on the value of exactly 2. Let's find the probability that we see at most 6 pages. So that would be 6 or less. So that would be the probability that X takes on a value less than 6 or equal to 6. And the probability that more than 3 pages, that would be the probability more than would be greater than. X is greater than 3, and that is 1 minus the probability that X is less than or equal to 3. Okay, so using the binomial distribution, this would be, let's just go to the next slide. The probability that X is equal to 2 would be binom PDF. And I'm going to show you how to do this on your calculator, because you can put the probability of a success in your calculator as a fraction, and it will calculate it for you. So you don't have to calculate it and then put a decimal approximation in there. Your calculator can handle the probability of a success being a fraction. The probability that X is less than or equal to C, we'd use a binom CDF. And the probability that X is greater than 3, we're going to have 1 minus the probability that X is less than or equal to 3. And then you can see also here that we calculated the mean and the standard deviation. So I'm going to go over to my calculator. All right, so I'm going to first calculate the probability that X is exactly 2. So I'm going to go to my distributions. I'm going to find my binom PDF. All right, the number of trials is, I'm looking at 100 pages. The probability of a success is there are 8 pages out of the 560 that feature signature artists. So this is 8 divided by 560 is the probability. If I randomly look at a page in this catalog, that it would feature a signature artist. Since there are 8 successful outcomes out of 560 possible, the probability is 8 over 560. And we're interested in what? X equals 2. So we have a binom PDF, 100 trials. The probability of a success is 8 over 560. And we're interested in when the probability that the random variable takes on exactly a value of 2. And that is 0.2466. So again, you can put in the probability of a success just using a fraction. All right, so now let's look at the probability that X is less than or equal to 6. So we're going to go back to our distributions and we're going to find the binom CDF. That's the cumulative probability. And now the number of trials is 100. There are 8 pages out of those 560 that contain a featured artist. And then we're going to look for X is less than or equal to 6. So our value is 6. So the binom CDF 100, 8 over 560, 6. So that's going to be 0.9994. All right, now to find the probability that X is greater than 3, I need to find the probability that X is less than or equal to 3 and subtract that from 1. So I'm going to start this on my home screen. I'm going to go 1 minus, and then I'm going to go do the binom CDF 108 over 563. So I'm going to go back to my distributions. And all I need to change is my value. I just need to go down here and change this value, the X value, to 3. So my calculator is now going to calculate 1 minus the probability that X takes on a value less than or equal to 3. Which is 0.0557. Are there any questions? Okay, then let's finish up and let's look at a problem in your homework. I don't remember what number this is, 8 or something like that. This is problem 8, I think, in section 4.3. So section 4.3 should all be binomial, kind of like a default. Since you're doing a section on binomial distributions, you would expect all your problems to be binomial distributions. But let's look at it. 8% of all Americans live in poverty. Well, that's not a success. But in our case, that is what we're going to use for P. So P is going to be 0.08. If 43 Americans are randomly selected, so that's going to be the number of trials that we look at, find the probability that exactly 2 of them live in poverty, at most 4. So the first 2 we've done examples of. Exactly 2. So we're going to have our number of trials. This is going to be a binomial with the number of trials being 43. and the probability of a success being 0.08. So the first one, exactly 2, is the probability that X takes on a value of exactly 2, which would be a binom PDF. Number of trials is 43. Probability of success is 0.08. We are interested in taking on a value of exactly 2. So binom PDF 43.08, 2. Okay, the next one, at most 4. This is the probability that X is less than or equal to 4. At most means 4 or less. And this is a binom CDF. 43.08. And then we're interested in less than or equal to 4. So our value would be 4. Okay, so the last two are a little trickier. Well, they're a lot trickier. At least 1. At least 1. So that means 1 or more. All right, so this is discrete, which means your calculator, when it calculates the CDF of 1, it finds the probability of 0 and 1 and adds those together. So if you're using binom CDF where the value is 1, it finds the probability that X takes on the value of 0, and it adds to it the probability that X takes on a value of 1. It adds those two together. So if what I'm interested in is X is greater than or equal to 1, I have to find the probability that X is 1, 2, 3, 4, 5, 6, 7, 8, etc. What do we got? 1, and add those up through 43. So I have to find the probability X is 1, probability X is 2, probability X is 3, the probability X is 4, all the way up to 43, and then subtract that from 1. So what I can do then, let me repeat this. So to find the probability that X is greater than or equal to 1, I have to find the probability X is 1, add to it the probability that X is 2, add to it the probability is X is 3, etc., etc., etc. So what I could do looking at this, well, this would be the same as 1 minus the probability that X is 0. If we look at the probability of 1 plus 2 plus 3 plus 4 plus 5, etc., 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 the only thing that's missing here is the probability that X takes on a value of 0, which you could. So if I find the probability that X takes on a value of 0 and I subtract it from 1, then I find the probability that X takes on a value greater than or equal to 1. So what I do here, and I can use the cumulative. It doesn't matter in this case whether I use cumulative or just the PDF. It doesn't matter. I just kind of default. And that will give me the probability that X takes on a value greater than or equal to 1. So 1 minus the probability that X is less than or equal to 0. That'll do it for me. All right, so what about between 2 and 6? So one way to do this would be to find the probability that X is equal to 2, add to it the probability that X is equal to 3, add to it the probability that X is equal to 4, etc., etc., etc. But what I can do, which may be a little bit easier for me, is to use the cumulative probability. So this I can find. using the cumulative probability. So I can find this. Now, what I need to subtract off to be able to get the 2, the 3, the 4, the 5, and the 6, then I need to subtract off anything less than or equal to 1. So I need to subtract off this over here. So if I take the probability that x is less than or equal to 6, and I subtract off the probability that x is 0 or 1, then I'm going to get the probability that x is between 2 and 6. So I'm going to subtract off the probability that x is less than or equal to 1. And when I do that, that'll give me the probability that x takes on a value of 2 or 3 or 4 or 5 or 6, because that's what I'm interested in, that the probability is between 2 and 6. So I take the probability that x is less than or equal to 6, which would be 6, 5, 4, 3, 2, 1, and 0. And I subtract off from it the probability that x is 1 or 0. Take those off, that gives me the probability that x is between 2 and 6. So you've got a couple of problems where you have to do both of those. So keep this in mind when you're working on those two problems, those few problems. All right, and that's really all I have for today. I talked for 45 minutes. Are there any questions? Now, you had a test due yesterday, and I know not all of you have done it. That's okay. You can use a late pass to take your exam late. So you can do that. So try to get that done before your late passes run out. Are there any questions? I heard them unmute.
Thank you, Ms. Castle.
Well, thank you for showing up. Well, if there aren't any questions, I'm going to let you go. I'm going to stop the recording.